Et ben a priori c'est bon.
The team leader itself will give you in a few moments some additional information, so I hand over.
Well, my name is Philippe Pisnard, I'm French, and I came from the University of Angers, where this robot has been designed. So this robot is a prototype and has been designed with very special specifications. So we wanted to build a robot that is able to pass through several obstacles like stairs or curb, or to pass inside a large pipeline, for example. And we also wanted that the robot can be carried by a soldier or by a human. So the robot is not very heavy, it's about 10 kilograms. And the robot can stand in the middle, and we have a special mechanism that guarantees the tension of the caterpillars. So this special design allows us to pass through several obstacles and also to pass through obstacles and to pass in a very thin corridor, because when the front part is in the upper position, the robot is very maneuverable. So, and the last point is that it's a prototype of the university, and it's a very cheap robot, maybe one of the cheaper of ELROB 206. Thank you.
Thank you very much to the team leader of the University of Angers. Now the robot B2P2 is approaching the actual training area. Again, also this tool has a total of 50 minutes to fulfill the task to detect the explosive devices which have been put in the training area. So there are still more than 45 minutes left to fulfill the mission. Some additional information about the team from France. The team is mainly composed of members and students from the laboratory depending from the University of Angers. This laboratory is called LISA. The laboratory is specialized in the field of automation, robotics, and virtual reality. Other members of the team are students from the University of Angers. Unfortunately, there is a minor technical problem. The robot lost its track, but it will be repaired right now. And afterwards, the robot will continue to fulfill its mission. For some close-up pictures, you just need to look to the right-hand side on the big screen, so you will see the robot in a close-up. And it will now enter the actual training area. Some additional technical information. Its height is 60 centimeters, including the antenna you can see. The length is also 60 centimeters. The width is 50 centimeters. The weight is around about 10 kilograms, including all equipment. The ground clearance is 4 centimeters. And the climbing performance is up to 45 degrees. The robot is track-driven. The propulsion is delivered with batteries. The endurance is 2 hours. And the maximum speed is 3 kilometers per hour with a payload of up to 2 kilograms. Sensors mounted on this robot are 2 cameras, like normal webcams, as you might know them from your personal computer, and 4 encoders, 1 on each motor. It carries 1 computer with 3 CPUs. The mandatory number of operators for this robot is just one operator, and up to 5 optional operators. Operating system is Linux and Windows XP. The weight of the control station placed in the tent behind me, where the operator operates the robot without direct line of sight, is 20 kilograms, and the power source needed is quite normal, so 230 volts with 500 watts. So again, the challenge for the operator is to rely on the sensors mounted on the robot, the 2 cameras, and it's now advancing inside the training area. But still 40 minutes left. The robot is currently exploring the training area and already detected at least one of the explosive devices. The operator could see it on his screen with the picture provided by the two cameras mounted on the robot. And there are still 35 minutes left to detect further explosive devices. 30 minutes left for the mission of B2P2, the robot of the University of Angers. In parallel to this ongoing mission, we will start in 10 minutes, so at 15:30, the next trial for the detection of EODs in vehicles and the house. This will be the Team Kinetic with its robot Taylor. You can see it already behind the tent. It's ready and start will be now in around about 8 minutes. The Kinetic team is a company which entered the ELROB 2006, largely composed of research engineers from Kinetic Research Facility based at Farnborough in the United Kingdom. Operating as part of the Kinetic Land Systems division under the leadership of Mr. Simon Cristoforato and Mr. Tim Young, the Kinetics team attendance at this event is supported internally without sponsorship from outside organizations. The vehicle they have put into the trial is called the Talon. This version of the Talon robot is based on the proven and fielded design of remote control vehicle developed by Foster Miller and Kinetic, owned company based in the USA. It is an all-electric powered vehicle based on a lightweight skid-steer high-mobility chassis. The vehicle is actuated via a wireless digital radio link to the integrated drive-by-wire system developed by Foster Miller for its range of remote control bomb disposal vehicles. The Talon vehicle is of a rugged basic design, being fast and light, and it's capable of climbing stairs and moving over unstructured ground. The route and environment is perceived through a number of low-light full-color cameras. 4 of the video pictures can be simultaneously sent to the control station in the tent behind me to allow the pilot to command the RCV to avoid collisions with obstacles in real time while advancing the route. The development of the Talon system began following requests from the US Department of Defense to develop a vehicle that could de-risk tactical and EOD operations. Over 200 Talon RCVs are in service with the forces operating in Iraq. At the time of the initial team application, this Talon vehicle is in regular use and has logged dozens of hours of operational service on Kinetic proving grounds. So starting in 5 minutes, we will then have 2 presentations in parallel, still ongoing. The robot B2P2, you can see on the green field, exploring the training area for another 25 minutes. And in 5 minutes we'll start the Kinetic robot named Talon right behind of the tent to explore the vehicles and the house.